Have you ever had a brilliant idea? An idea so clever it could change everything? Well, meet Léo Dubois, a 17-year-old high school student from Paris, France. Léo is a thinker, a builder, and now, an inventor. He noticed a problem in his chemistry class, a small but frustrating hurdle that slowed everyone down. Instead of just complaining, he decided to do something about it. He used his curiosity and his love for creating things to build a solution. This is the story of how one young mind decided to make science a little bit easier for everyone. It all started not with a big explosion, but with a simple question: can we do this better? Léo's motivation came directly from his own experience in the classroom. He watched his friends, and even his teachers, struggle with a repetitive task. It was a part of chemistry that required careful calculation, and one tiny mistake could throw off an entire experiment. He saw the frustration on their faces, and felt it himself. He thought about how much time was spent double-checking math, instead of focusing on the amazing reactions happening in their beakers and test tubes. This wasn't about getting a better grade, it was about making science more accessible and more fun. He believed that if he could remove this one obstacle, students could spend more time learning and discovering. So, what was this big problem? It was the conversion between grams and moles. In chemistry, a mole is a specific number of atoms or molecules, kind of like how a dozen means 12. Scientists need to know how many moles they are working with, but they measure substances in grams using a scale. To go from grams to moles, you have to do some math using the atomic weight of the element from the periodic table. It's a crucial step, but it's also easy to make a mistake. Léo dreamed of a tool that could do this conversion automatically, giving scientists and students the right number instantly. This is where the idea for the Moltimetrul was born. The name itself is a clever combination of mole, the chemical unit, and multimeter, the French word gomar for a multimeter, a tool that measures many things. Léo imagined a device that looked like a digital scale but did so much more. You would tell it what substance you were weighing, like carbon, or water, or salt. And it would show you not just the weight in grams, but also the exact amount in moles. It was a simple idea, but one with the power to revolutionize how students and researchers approach their work in the lab every single day. Let's get into the science. The Moltimetrul is a truly ingenious device. Think of it as a super smart digital scale. A normal scale tells you the mass of something, right? You put an apple on it, and it says 150 grams. The Moltimetrul does that, but it has an extra brain. Before you weigh your chemical, you use a simple interface, a small touchscreen or a dial, to select the chemical compound you are using, like H2O for water or NaCl for table salt. The device has a built-in library of common chemical formulas and their molar masses. It's like having a periodic table and a calculator inside your scale. Once you've selected your substance, you place it on the weighing platform. The device measures the mass in grams, just like any other scale. But here's the magic. Instantly, it performs the calculation that used to take a student several minutes. It divides the mass in grams by the molar mass of the substance it already knows. The result is displayed right there on the screen, next to the weight. So you see 18.02 grams and right below it, 1.00 mole. No more calculators, no more looking up atomic weights, and no more simple math errors. It's that easy. The benefits for students are enormous. Chemistry can be intimidating, and for many, the constant math is a major barrier. The Moltimetrul removes that barrier. It allows students to focus on the concepts, what a mole actually represents and why it's important, instead of getting bogged down in arithmetic. By making this step faster and more reliable, it builds confidence. Students can move through their lab experiments more smoothly, getting immediate feedback and connecting the physical substance in front of them with the abstract chemical quantity. It helps turn a moment of potential frustration into a moment of understanding. And it's not just for students. In professional laboratories, time is incredibly valuable. Scientists and technicians perform these conversions hundreds of times a day. While they are very good at it, mistakes can still happen, and even small errors can compromise expensive research. The Moltimetrul offers a way to increase efficiency and accuracy. By automating this simple but critical task, it frees up researchers' mental energy for more complex problems. It reduces the chance of human error, making experiments more reliable and reproducible. It's a tool that helps everyone, from the first-year student to the Nobel Prize-winning scientist. Leo's journey to creating the Moltimetrul didn't start in a high-tech lab. It started in his childhood bedroom, surrounded by wires, circuits, and dismantled toys. Ever since he was a little boy, Leo was fascinated by how things worked. He would take apart old radios, remote controls, and anything else he could get his hands on, just to see the components inside. He wasn't just destructive, he was curious. He would try to put them back together, sometimes successfully, sometimes creating something entirely new. This early passion for tinkering taught him the basics of electronics and problem-solving. He learned to be patient and to see failure not as an end, but as a learning opportunity. The Moltimetrul project began as a rough sketch in a notebook. Leo combined the design of a digital kitchen scale with the processing power of a simple microcontroller, like an Arduino. His first prototype was a clumsy thing, made from a repurposed scale, a breadboard, and a mess of jumper wires. It barely worked. He spent countless weekends and evenings in his garage, experimenting with different sensors and coding the software. He had to teach himself how to program the device, to store the molar masses of different elements and compounds, and how to create a user-friendly interface. It was a process filled with trial and error. He wasn't alone on this journey. Leo shared his idea with his chemistry teacher, Madame Renaud. She was immediately impressed by his ambition and provided crucial guidance. She helped him refine the list of chemical compounds to include in the device's memory, and gave him feedback on what features would be most useful for students. His friends also played a big role. Some helped him with the coding, while others listened as he explained his challenges, often leading him to find his own solutions just by talking it through. This collaborative spirit was essential to turning his rough prototype into a polished, working invention. The culmination of his hard work came at the annual Paris Youth Science Competition. Leo stood proudly next to his booth, where the final version of the Moltimetrul was on display. It was sleek, professional, and it worked perfectly. Judges, teachers, and fellow students gathered around as he demonstrated how a pile of salt could be weighed and converted to moles in seconds. The feedback was overwhelmingly positive. People were amazed that such a simple and elegant solution to a common problem hadn't been invented before. His project didn't just win an award, it started a conversation about how innovation can improve education. The success at the science competition was just the beginning for Leo and his Moltimetrul. The recognition he received has opened up new and exciting possibilities for the future of his invention. Leo is already thinking about the next version. One of the top ideas for improvement is to add Wi-Fi or Bluetooth connectivity. This would allow the Moltimetrul to connect to a computer or a tablet. Imagine a classroom where every student's measurement is instantly sent to a shared digital lab notebook. The teacher could monitor the entire class's progress in real time, offering help exactly when it's needed. This would make lab work even more interactive and collaborative. Another potential upgrade is to expand the device's internal library of chemical compounds. While the current version holds the most common substances used in high school chemistry, a professional version could store thousands of different compounds. Leo also envisions adding a feature that helps with stoichiometry, the part of chemistry that deals with the quantities of substances in reactions. The device could guide a user on exactly how many grams of a second chemical they need to create a perfect reaction, taking even more guesswork out of the process. The possibilities for making the Moltimetrul an even more powerful lab assistant are practically endless. The journey of the Moltimetrul teaches us a powerful lesson. It shows that you don't need to be a famous scientist with a giant laboratory to make a significant contribution. Innovation can come from anyone, anywhere, at any age. It often starts with noticing a small, everyday inconvenience and having the curiosity to ask, why is it like this? Leo's story is a testament to the power of a single idea when it is combined with persistence and a passion for problem-solving. He saw a challenge not as a roadblock, but as an opportunity to create something new and helpful for his community. Ultimately, the story of Leo Dubois and the Moltimetrul is a wonderful example of how simple ideas can have a big impact. His invention has the potential to help countless students find more joy and understanding in chemistry, and to help scientists in their quest for discovery. It all began with a teenager who liked to build things and wanted to help his friends. It's a reminder to all of us to keep our eyes open for problems to solve, to embrace our curiosity, and to never underestimate the power of a good idea. Because sometimes, the smallest spark of ingenuity can light up the world of science. Consider the world, and you can change it.